Good morning, everyone, or good afternoon, depending on where you are. Thanks so much for joining today. We've got quite a lot of you on the webinar this morning and still a few rolling in. So I'm going to start with just a few introductory remarks. If you haven't joined one of these before, then let me just tell you a few little tips on how this is going to run and things you can do. One tip is to, in your Zoom client, is to set it to run full screen, and that way you should get the clearest view of the presentation I'll be sharing, and then when we jump into the software, you'll be able to see best what's going on. You'll notice I've made my mouse pointer large and pink, which seems to work fairly well in terms of being able to just track that, so look out for that. I'll be taking Q&A at the end of the webinar today. I'm going to go through the material first. Alice is downstairs helping run the show, and she will be monitoring the Q&A for any urgent questions. If you have a question, you can put it into the Q&A window. There's a button marked Q&A somewhere in your Zoom client. Depends what device you're on as to where it's going to be. But just throw your questions in there, and then I will answer some of those live at the end, and any that come up that need answers as we go, Alice will deal with some of those via chat. At the end of the webinar, we're recording this today, and after that, we'll edit it, clean it up, and we'll send a link out to everybody so you can view this again or on demand if you wish. And at the end, there'll be a very short survey. You'll get, I think it'll pop up the link right at the end, or it'll send it to you in email. And if you have a moment to fill that out, that would be very much appreciated. So it was very good to get your feedback. It was also great this time. I don't know why I haven't done this before, but I put in a Q&A, questions and comments field in the registration form, and a lot of you filled that out. So thank you for that. That's been actually very helpful in shaping the agenda and the material we'll cover today. So thanks for that. You'll see some of your questions hopefully popping up as we go along. If you're stuck on anything technical related to the software or the site, then you can email us at support@photoephemeris.com. We're not going to be monitoring that live during the webinar because we're both fully occupied doing this, and but we will follow up with any questions that come in there. So that's my intro remarks. We've got a good number of folks on now, and I think it's a good time to begin. So let me jump right in. What I'm going to do first is take just a few minutes. This webinar is intended really for beginner or intermediate eclipse photographers. So if you are an expert and you're an experienced astrophotographer, you're shooting with equatorial mounts and trackers and telescopes and the like, there may be something you'll get out of today, but we're really focused on the sort of beginner, intermediate eclipse photography audience today, just to put that in context. And with that in mind, we'll just take a few minutes now just to sort of level set everybody on what are we talking about with regards to a solar eclipse. I think we've all got a pretty good idea of what's involved, but let's just get everybody on the same page. So this is a little diagram from Wikipedia from the solar eclipse page that shows the sun, the moon, and the earth. And of course, an eclipse happens when there is, the technical term is a syzygy, one of those wonderful words with too many consonants, which is an alignment of three bodies in space. And as a result, the shadow of the moon is cast on the earth. Obviously, the moon is always casting a shadow all the time, but most of the time it's not landing on Earth. It's only when that happens that we have an eclipse situation. And there are a few different types of circumstances for eclipses. You'll all have heard of a total eclipse. Many of you will have seen a partial eclipse because those are the most widely seen. And you can sort of see that from this diagram where we have this penumbra. When you're in the penumbra, you're viewing a partial eclipse. Part of the sun is blocked by the moon. And sometimes the umbra, which is where totality happens, misses the Earth altogether, but the penumbra doesn't. So you can have a partial eclipse, say up in some of the polar regions, and no total eclipse or no annular eclipse either. This all happens, particularly the total eclipse and the annular eclipse phenomenon that we'll talk about today, Talks primarily because it happens primarily because the sun is around 400 times larger than the moon, but it's around 400 times farther away from Earth. And so when you look at them in the sky, and you're probably all familiar with that, they appear to be roughly the same size. Let's just jump in a little bit closer here. So I mentioned the penumbra, partial eclipse. If you're outside the penumbra, no eclipse. If you're in the umbra, what I've said here, this is a slide I had from a few months ago, and I'm going to clarify it because it needs to be a little bit more precise. Because today we're talking about the annular eclipse of the 14th of October. And there is no umbra during an annular eclipse. So I'm showing this shadow cone, or this diagram shows the shadow cone hitting the Earth, and there's the umbra. So that really should just say total eclipse. So let me explain why that is. So I modified the diagram a little bit. Here is the diagram as you saw it on a white background, and the shadow cone of the moon touches the Earth and forms the umbra. So that's when you're in the path of totality. But as you all know, I'm sure from hearing about so-called supermoons, the moon's distance from Earth varies at different times in its orbit and its cycle. And sometimes those close approaches, that's called perigee, when the moon is at its closest to Earth, sometimes that corresponds with a particular phase of the moon. So in the case of a supermoon, as you heard about in August and may hear about this week, that is when there is a full moon that occurs close to the time when the moon is closest to Earth at perigee. So that's a perigee full moon. You can also have a perigee moon at new moon, and eclipses happen at new moon because that's when the moon is in between the sun and the Earth. But in the case of an annular eclipse, we have a new moon situation around the time of apogee, i.e. when the moon is farthest from Earth. And when that happens, you may be able to see this. We'll drill in. I have it on larger on the next slide here. The shadow cone doesn't reach the surface of the Earth. And so if you were to project this notional shadow cone and the lines cross, sorry for my hands looming into the camera there, but you can see here where the pink arrow is pointed. What forms is something that's called the antumbra. That's the technical term for it. I don't quite know where the term comes from, but it's not a shadow necessarily. But the easiest way to think about it is the moon is farther away, it appears smaller in the sky, and so it does not fully obscure the sun. And so the moon appears entirely within the disk of the sun, forming an annulus, that's the Latin-derived term, which is basically a ring, also known as the Ring of Fire. So that's what we're talking about today, an annular eclipse. Annular eclipses, I believe, are slightly more common, I hope I've remembered this correctly, than total eclipses. But over the long term, they occur sort of roughly equally, as you might imagine that, they coincide when the moon is close or the moon is far. And on balance, they're roughly 50-50. I think there are slightly more annular eclipses than total eclipses. So there's the key points. We've got partial eclipse, which many of you I'm sure will have seen, the total eclipse, which hopefully some of you have seen or will see next April 8th, is the next one that occurs. And if you're not in the US or the Americas and you're looking for a total eclipse, the next big opportunities are going to be 2026 and onwards. There's a whole sequence through 26, 27, 28, 29, particularly in Spain, North Africa, and Australia are the geographies that are favored for those eclipse paths. Then annular, and I'll just mention quickly the hybrid eclipse. There was a hybrid eclipse occurred in April of this year, and that is when you have, it starts annular, transitions to become a total eclipse, or it starts total and then becomes annular, or it's annular, total, annular. And you can imagine why that is, that if the distance of the moon from the Earth is just enough that based on where you are on the curved surface of the Earth, the shadow cone either touches or it doesn't touch. When it doesn't touch, it's annular. When it does touch, it's total. And so these hybrid eclipses sort of live in this zone of where it's just enough to reach totality, sometimes not even quite that. There are a few very special cases that occur maybe every few decades where it's sort of not quite total, not quite annular. Anyway, roughly 2 eclipses each year, 6 months apart. So we have one in October this year. You have the next one in April next year. The partial eclipse phases will last a few hours, 3-4 hours, something like that. Totality can last up to 7 minutes at any single location. And when I say totality, I also include in that, in this context, annularity, i.e. if it's an annular eclipse, you don't have totality, strictly speaking, but you will, that ring effect can last similar sorts of durations. We're going to see around, I think, 4 minutes peak, something like that in October. But what you see depends on exactly where you are and exactly when. So we'll talk about that in a little bit of detail. And then what we will do is jump on to talking about the practical aspects of photographing this thing. What equipment, what sort of shot plans, what are you going to need to think about? So just a few pictures to get you in the mood. Partial eclipse from England, cloudy skies, but not quite cloudy enough to stop the sun being viewed. This is a partial eclipse. This was in Boulder, near where I live. And it actually was an annular eclipse, but in Boulder, I was too far north to be in the path of annularity. So what you're seeing is a partial eclipse towards sunset in the afternoon. Here's an annular eclipse. This one is from 20th of May 2012 in Nevada. There's the Ring of Fire. Notice that the moon is not quite symmetrical in the ring. So we'll talk about that because that's an important consideration for the sorts of photographs you may wish to take. What you're going to see depends on where you are on the path. So we'll look at that in a little bit more detail. Total eclipse. This is a shot of the corona. That's I think what they call the outer atmosphere of the sun. Extremely hot, extends an awful long distance from the sun itself. Typically only seen in a total eclipse, never seen in the partial eclipse, unless you have some super special equipment and filters to bring it out. You can do that at any time, actually, whether it's eclipsed or not, if you have the right gear, I think, to some degree at least. The other phenomena you see in this is pretty much taken at the same time as that shot, but with a different set of exposure settings on the camera, shorter exposure. And what you see there are two things. You see a little bit of the corona, and you see that little pink row there, that layer, that's the chromosphere. So chromosphere is in colored sphere. It's the about a 50, 100,000 miles thick layer just on outside the photosphere. The photosphere is what will blind you, what provides the light that we see during the day. The chromosphere exists outside that and can be seen during total eclipses and can be seen during annular eclipses if you go to some specific places and take appropriate precautions. Then we're also seeing a few prominences here. That's what these lumpy pieces are here. So we'll talk about this in the context of annular eclipses as well, but it's an advanced topic. It needs a lot of careful planning. If you haven't done it before, my best advice would be to find somebody who has and tag along with them to get yourself to the right place in the right time and know how to look at it, observe it, and or photograph it safely. Finally, this is the final photo shot. Total eclipse, that's the diamond ring. Just as the photosphere, so the light producing part of the sun, emerges from behind the moon. This is not really something you see in an annular eclipse. So this is something that's more associated with a total eclipse, the diamond ring effect. So a little bit of terminology, and then we're pretty much through all of the background material, and we'll jump into some practical stuff. So terms you will hear and really should understand are these terms C1, C2, C3, C4. And C refers to a contact time. And so first contact, second contact, third contact, fourth contact. So let's talk about this for a total eclipse, and then I'll show you what it means in an annular eclipse, because it's slightly different, but only slightly. C1 is the start of the partial phase. I'm showing you here a little screenshot from the eclipse simulator in Ephemeris web, and I've set it so that the sun is already about 10% obscured. That's simply because if I set it right to the instant of first contact, it would just look like a whole sun, because it's literally the instant when the moon begins to bite into the disk of the sun, and I mean that figuratively, obviously not literally. And then fourth contact is when the moon is departing its conjunction with the sun, and the sun is no longer obscured at all. So the obscuration, which is the sort of a measure of the percentage area of the sun's disk that is obscured, is 0 at both C1 and C4. So these times, we'll look at the timings in a bit more detail, but that's the roughly 3-hour duration of the eclipse. So if you were photographing a whole sequence, you would probably start a bit before C1 and finish a little bit after C4, just to give yourself enough space in the composition and time to get set up, take a few exposures, check your focus, check your exposure, etc., etc. C2 is the start of totality. So it's basically the moment when the diamond ring vanishes and the sun is completely obscured. So at that point, obscuration is 100%. And magnitude, which is a measure of the ratio of the disks, of the moon's disk to the sun's disk that is covered, is greater than 1. So magnitude 1 means total eclipse, 1 or greater. Maximum eclipse is not, strictly speaking, a contact time, but it's a time that you often see quoted in conjunction with the other contacts. And it's basically the time when the sun is deepest behind the moon's disk. So it's the time of maximum. I got to be careful with the terminology here, because I'll get picked up by the real eclipse experts who are very precise on these things. But it's basically the point of deepest eclipse of the sun. C3 is the end of totality. The photosphere emerges again, and you can see in this one it's merging more or less on the opposite side of the moon or the sun, whichever you wish, and that is a characteristic of where you are on the eclipse path. We'll see that now in the context of an annular eclipse. So here's sort of the same slide. I didn't have any nice photos of an annular eclipse to illustrate this with, so I've used the simulator that we'll dig into a little bit more. This is C1 in annular, but that's 10% in. This is 10% before it finishes. But C1 and C4, first and fourth contacts, mean exactly the same as they do in the context of a total eclipse. It's the start and the end of the partial phase. So that's fine. C2, second contact, is the start of annularity. I'm not sure if that's a real word or not, but it seems fair enough. And that is, you see here, the obscuration, which is this number. Well, I'll show you it larger later because it's a little bit small and hard to read, but it says 89.8%. And you can see here the moon is too small to cover the sun, but the disks are what is called tangent to one another, i.e. touching, but they're touching, it's an interior tangent. So it's not this edge of the limb of the moon is just now within the limb of the sun. So that's the definition of second contact for annularity. And that is basically the start of when you will see the formation of the ring of fire. If you are on the central line and you get to the maximum time of annularity, then it all looks beautifully centered and symmetrical. So that might be something that's important for your photographic objectives for this. And we'll talk about what happens if you're not on the central line and some things about how to be certain where the central line is. So there's a few considerations here. And then at the end of annularity, third contact, the moon is just at the point of moving outside the bounds of the limb of the sun's disk. And so you can sort of infer between C3 and C4, the moon is drifting out of the sun that way. These photos are sort of centered on the average positions of the simulations are centered on the average of the positions of the sun and the moon. So the whole thing is moving through the sky as a pair, but coming apart as you approach C4, for example. Okay. An annular eclipse, what are the things to look out for? What might you see? So we've talked about this. Well, clouds permitting. We'll talk about weather shortly. You'll see the partial eclipse phases if you're in a wide area of North America and South America. Not so much in Europe. We'll come on to that, or elsewhere in the world for that matter. But around 3 hours in duration. If you're well inside the path of annularity, you will see an unbroken ring of fire. So that is the moon entirely within the sun's disk. And you possibly may see Bailey's beads. That's what this is a still image from it's a really neat video on YouTube of the annular eclipse, again from May 2012. And this is taken with a solar filter. You can sort of tell that, well, A, because you need to keep it safe. We'll talk about those. But also just this sort of slightly flattened light. And you see here where you have this sort of broken ring effect. That is to do with the detailed topography of the limb of the moon, and it has mountains and valleys, and light can pass through the valleys but can be blocked by the mountains, and as a result you get these edge effects, these limb effects, which result in what's referred to as a broken annulus. And if you've seen images of Bailey's beads, Francis Bailey was I think a British astronomer. He first described these in a published paper in around, I think, 1836 or thereabouts, and he observed them for the first time during an annular eclipse, not a total eclipse. And that's because they're frequently observed with annular eclipses, and you'll see why as we sort of explore some of the animated simulations. When you photograph it with a filter, though, they don't sort of sparkle as they do when they're often photographed with a total eclipse. So with a total eclipse, you don't have to deal with this blindingly bright photospheric sun that is not obscured by the moon. But in an annular eclipse, that is present. And so the only, well, not the only, but pretty much the safe way to observe it and photograph it is with a solar filter on your camera. And as a result, it sort of looks it looks a bit more tame, if you will. There's not that sort of, sometimes called the diamond necklace as well as another term, but that's not giving you the sort of the diamond effect because of the filter. So if you're near the edges of the path, you'll see this broken annulus. You'll almost certainly see quite a lot of Bailey's beads, which can be extended through the whole C2 to C3 time period, or even continual, depending on where you are. And we'll talk about how that works. You may see the chromosphere or the prominences that we talked about in the context of the 2017 total eclipse, and you may even see some corona. That's probably the least likely thing you'll see. But the rest of it, if you're near the edge, you stand a good chance of seeing that. I said we'd talk about weather, and we shall. What we want, certainly if you are, you'll see that the path for this annular eclipse is sort of sweeping down this way. It comes through Oregon, across Utah, New Mexico, Texas, San Antonio, cuts across the Yucatan, down through South America. And what we're really hoping for is skies like this, because this looks pretty good, apart from Oregon. This is from windy.com. Windy.com is a great site. It has a lot of different weather models that you can explore. The received wisdom is that the weather forecasts begin to become reliable around 5 days out. So you can look 10 days out. I mean, I often look 10 days out on my phone, and it very much depends on where you are. In Colorado, the 10-day forecasts can be pretty good. They're not always, but they can be fairly reliable. Other places, if I were living back in the UK, that would certainly not be the case, I think, because of the unpredictability of weather systems and high cloud, etc. But you can make a judgment call on when you want to start relying on them. But 5 days out, things should start to line up. So check the weather forecasts regularly. Given that the title of this webinar is last minute planning, we're sort of not too far off from that date anyway. However, there is another site that I would let you be aware of, and I'll put all these links in the chat before we finish. Eclipsophile.com. A gentleman called Jay Anderson has been producing historical weather analysis for eclipses for many years, and he has a page dedicated to the annular ASE 2023 annular solar eclipse of 2023, which talks about which locations have the highest probability of clear skies along the path of the eclipse, as well as some maps. So check that one out, eclipsophile.com. You'll see the link from the homepage, but it's ASE 2023. So that's the weather considerations. So from now on, I'm going to assume that we have perfect weather and all is well. Let's hope that is the case. We're going to jump across into using Photo Ephemeris Web to look at some of this eclipse information. And the key thing is to understand what are you going to see and for how long. It's going to depend on your location and obviously showing up at the right time and the right date and so forth. So some of the questions, the sort of generalized location questions that I received, and thank you again to everybody who submitted questions. How far off being exactly on the path of the eclipse can you be and still get good images? Now, the path, you could infer that to mean two things. It could mean the central path, or it could mean the path of annularity. So I'll look at both of those questions. Catherine asked, how much will be visible in the eastern US? Alan asks, will it be visible in Oregon, Washington, Ohio, Idaho? So let's look at some of those questions. So I'm going to click here to app.photoephemeris.com. If you haven't used this before, I'll just quickly go through some basics on how to do it. I've just started from today's date and generic location in Colorado, and I'm going to show you how to bring up the October 14th eclipse information. So first of all, we're going to get to the right date. There are a couple of ways to do that. We'll do October 14th, 23, hit return, and we're right there. An alternative way is to click on the list of events here, and I bring that up, and you'll see that October 2023, Saturday the 14th, maximum eclipse, annular eclipse. So you could select that event that way as well, and that will get you to the right date. Now, as it happens, I had the pin in Colorado, and it loads the eclipse map. So let's just talk about what are we actually looking at. I'm going to click outside of this range, just get rid of the simulator for now, because we'll talk about that in a moment. The first thing is that I have three or four different types of lines shown. The pink line, or the pink path, the pink shaded area, is the path of annularity. So if you are in a location within this path, you will see the ring of fire to some degree. It may be broken if you're close to the edges of that. If you're outside of the pink area, you will not see the annular eclipse. But if you're anywhere within these purple lines, typically the solid purple lines, you'll see a partial eclipse. So for example, let's just go, I'm going to go to Boulder, Colorado, which is where I am. And I'll just zoom back out again, but the map pin is there. And you can see that I'm outside of the path of annularity, but I'm within some of these purple lines. The purple lines that you see are basically lines of equal magnitude. And if that is the central line and that is the northern limit, then you can see that is 80%, 60%, 40%, 20%. So if I now click maximum eclipse in the timeline here, you've got all the first contact, C1, max eclipse, and C4. You may say, but where's C2 and C3? Well, they don't occur because we're not in the central path. Let's just look at max eclipse, and that's what you would see at 10:35 on the 14th of October from Boulder. You can see that the sun is 78% obscured, and the magnitude is 80.84. Remember, magnitude is sort of a linear ratio of diameters of the disks and how much they overlap. And obscuration is a percentage of area of the sun that is obscured or covered by the moon. So in answer to the question, what can you see in Idaho? Let's just drop the pin in Idaho. That's one of the nice things I think about this tool for this sort of planning, is that you can very, very quickly just drag and drop the pin anywhere you want, and in an instant see exactly what you're going to be able to visualize or observe on the day, weather permitting. So in Idaho, it's sort of similar, 79%. If you go north, however, let's just click up here into very northern Idaho, you'll see that we're down to 71%. So the further you go from the pink path, the less obscured the sun is. You're seeing a partial eclipse. So far, so good. Eastern US, well, it depends whether you mean the northeast or the southeast. Northeast, so New York State. Again, one tip, if you drag and drop the map pin a large distance, it doesn't change the selected time of day. So you might think, well, it was on maximum eclipse back in Idaho and I moved it to New York and now maximum eclipse looks even worse, which it does, but it's not maximum eclipse anymore because we're at 12:41, which is where we were in Idaho. But the maximum eclipse time in New York is later, it's 1:16 and the time's unchanged. So that's what you'd see in that part of New York. If you drop down to Georgia, you see we've moved within this line of 60% magnitude. Did I mean 60? Maybe I meant 40. Yeah, magnitude, there we are. So it's 0.63 magnitude because we're inside of that line. If I drop it right on that line, we should see that, yeah, 0.5978 is the magnitude. So this is how you can explore locations. Let's zoom out. Let's look at what happens over here. Let's say we come to Spain. There is no eclipse visible there. So at some point, I'm going to write the code to join the dots, or it's a bit more sophisticated than that, but join the dots to the ends here, which starts to show you sort of the eastern and western-ish limits of the eclipse. So in Portugal, no eclipse. What about down in Colombia? Yes. And remember, again, select maximum eclipse, and we're up to 86, 87%. It's still not a fully annular eclipse. So now let's just click down to a location in that path. So I've just dropped it sort of near the central line, and now click maximum eclipse, and that's what we're going to see, a symmetrical ring. Let me just click back here. I think I've sort of answered those. So we need to talk about this question a little bit more. How far off the path can you be and still get good images? You can get good images pretty much anywhere, but it's sort of it depends what are you looking to achieve with your shot. You can get a great sequence of a partial eclipse, and it'll still look good, but it may not be what you'd hoped to photograph. So let's just look at this. We'll come to New Mexico, and there's Farmington. There's this road that runs north-south. Is it the 395? I forget. If I were to position myself on the central line, click maximum eclipse, symmetrical ring, zoom out slightly. If I were to go towards the northern limit, so directly north, click maximum eclipse, I get an asymmetrical ring, but the ring is still there. Let's just go straight south from there and click maximum eclipse. Now it's asymmetrical, but because we're the other side of the path, the asymmetry has changed. So the type of image you're going to see will vary based on your north-south position on the path, and the timing will vary slightly as well. So if you're looking for a symmetrical ring, you want to be somewhere on the central path, and then that's what you'll get. Let's just go from second contact. So it's contacting up there just at about half midnight, if you will. and it departs at around 6:37 p.m. of the clock. That's I'm sort of imagining clock numbers around the disk of the sun here, not the time of day specifically. And your window for shooting that is approximately 5 minutes. In fact, it's 4 minutes 49.2 seconds. So if I click C2, it tells you how long it is to C3. So that's a quick way of working out how long will I have. That's another consideration for photographing, is the more time you have to nail the shots or sequence of shots, because I think you're going to be wanting to shoot fairly continuously through the event, depends on where you are on the path. So let's look at those same pair of locations again. So 4 minutes 49 on the central line in New Mexico. Let's come up just within the limit here. Click second contact, 2 minutes 37. Let's go back down here, around there. Click second contact, 2 minutes 20. It's varying as I get closer to the limit line. What's interesting is that you actually have quite a large degree of latitude of movement around the central line without losing much in the way of duration. So let's just go, for example, here. Let's say I'm, a few miles south on that road. I'm off the central line. I still get 4 minutes 42. So it's almost as much as I had right on the central line. But what you don't have is quite the same perfect symmetry. You see how that is slightly thinner that side than it is this side. So central line for symmetry of the ring, central line for maximum duration. You can be off the central line, still get a good amount of duration, 4 minutes 42 seconds. Even down here, that's around halfway between the southern and the central limit. Click C2. I've still got 4 minutes. So it falls off rapidly as you get to the edge. So if I go just within that edge, 51 seconds. So hopefully that lets you consider time, duration, how long is this thing going to be observable for, photographable for. But of course, the other trade-off is what you're going to see. You will not see on the central line some of the things that you will almost certainly see closer to the limits. We'll talk about that in some more detail too. Here are a few questions that came in from folks who are basically going to be outside the path of annularity. So, for example, Oakland, California. Let's just look at that one. What is Oakland going to look like here? We'll come in. I'm just approximating here. Oh no, that was pretty good. You can see that maximum eclipse, you're going to get about 77%. So you may want to consider a drive out over Nevada. That might be the quickest way out there. Is that I-80? Maybe that's not I-80, is it? Maybe that is. But you could head out there. It's a good few hours drive, I guess, and that would put you in the path. So that's Oakland. Rio. We had a question for what can we see down in Rio. Let me just wait to get this. There's Rio. So click Rio, and you can see that it's central line 80%, 60%. So I would expect that's going to be around 50%. In fact, it tells you right there in the timeline as well, a magnitude of 0.5. So you'll see a half obscured sun, and that's almost certainly going to be a plane ride to get onto the central path there to see something like that. Similar for Southern California. You're going to need to sort of head up beyond Vegas up in towards Utah to get on the path if you want to see the annular eclipse. In the path of annularity, these were some of the places that folks are thinking of going, and all of these lie on the path. I won't go through all of them. I thought this was an interesting one. I hope that's pronounced correctly, in Colombia. there we are, that'll do. So let's look at that location. So that's great. That is very close to the central line. You will have 5 minutes 15 of annularity. Contact there, departs there, and a nice symmetrical view of the at maximum eclipse. So any of those locations are sort of lying on the pink path, and that's all great. You will see this annularity. So the next set of considerations really is around how do you photograph it. So we're going to sort of leave the software side of things behind, and we will move on to, let's talk about eye safety first of all. Super important topic. Here are sort of the key points. Never look at the sun without certified solar eclipse eye protection. And what does certified mean? It means try to get it from a reputable supplier, and try to confirm that the items you're buying or using conform to this ISO standard. That's the standard that should guarantee that they're going to give you suitable protection. So this really is around the degree of reduction of light across the eclipse glasses, and the key thing is two things. Read the instructions before you use anything. This applies both to eclipse glasses and also filters that we're going to talk about next, and also inspect them carefully before you use them. Don't use anything that is damaged, scratched, creased, folded, and anything that might give a light leak, because the slightest light leak looking at the sun could damage your retina permanently if you're not very careful. Sunglasses, no. ND filters, no. Stacked filters or sunglasses, no. I mean, generally stacking filters is not desirable because it just impedes the optical performance of the camera system, and you don't pick up your camera filters and try to look at the sun through those either. Not a good idea. So use specialized eye protection. And the other question is, when do you need to use that? You need to use, for this annular eclipse, you need this if you're looking at the sun, not looking through your camera with precautions that I'm going to talk about. You need it the whole time. So anytime you look at the sun, don't look at the sun and look at it for half an hour without looking away. Look at it for 10, 15 seconds through your eyeglasses. Look away, give your eyes a rest. Super important, so please don't forget that. You'll notice this little red warning symbol in the simulator that appears whenever you need to wear your eye protection, which is basically the whole time. Maximum eclipse, second contact. The sun is not obscured, it's still literally blindingly bright. If we looked at a total eclipse, let's just put that pin sort of on the central path, just before second contact, you need eye protection. Once you're into totality, that is the only time during any solar eclipse that you can look at the sun, because you're not looking at the sun. You can look at the moon obscuring the sun directly without eye protection, but that's the only time. So whenever you see the red triangle there, when you're planning out these things, if you see the red triangle and you're looking at the sun, you need protection. Okay, do I need a solar filter? Yes, very simple answer to that. So I've tried to make this fairly blunt. If you don't have one and you try to photograph the sun, you'll probably melt your camera sensor. Or worse, if you're looking through an optical viewfinder on an SLR, you will permanently damage your eyesight. And of course, the danger of that increases greatly with longer telephoto lenses. So yes, you need a solar filter. One other thing, we're going to talk about different solar filter types because they can be quite different in how they perform and what you get. But do not assume that the solar filter designed for photography is suitable as eye protection. It may not be, and I probably should have said it is not designed as eye protection. Read the manual, and if you're looking through the camera, typically don't use the optical viewfinder at all, use live view, or if you have a mirrorless camera or similar, use the electronic viewfinder, which obviously is your probably only choice. But on an SLR, don't use the optical viewfinder. Some cameras have the ability to put a little shutter down over the optical viewfinder. Recommend that you do that, just so there's no chance of you glancing through it, filter falls off, there's a hole in the filter, anything like that. And a few people asked about which filters to use. These are not suitable for partial and annular eclipse photography. UV protective filters, so there's sort of clear glass, but they cut the UV. That's not going to do it. ND filters, no. In some places online, you'll see folks say if you have 16 stops of an ND filter, that might be okay. If you're in cloudy conditions or semi-cloudy, like that photo I showed you from the UK a few years ago, I will confess I did cheat and I did use a 16 stop ND for that, and because of the clouds were there, it was fine, but that is not the recommended approach. Use a solar filter, not an ND filter. You do not need a polarizer; it's not going to help. Don't need ND grad filters, and probably not stacking filters either. That's just going to reduce the quality of your shots. Now we'll talk about which filters you can get, and there are plenty still available online. I had a look just yesterday, so it's not too late if you don't have one to buy one. And there are options at various price points as well, from very cheap to not very cheap. Now let's talk about focal length and field of view. I know a lot of you are thinking, how am I going to photograph this? Am I going to have a wide angle shot? Am I thinking of a composite? Do I want a foreground? Do I want a telephoto shot? So this is sort of going to be one of those keep it real situations. So the takeaway, I think, from my perspective, I'm not saying this is the only way to do it. It's not, but we're going to need a bigger lens. That's probably the way to get the most satisfying results. Here are a few screenshots. I took these from TP3D on my iPad earlier this morning. And this is a location in New Mexico. It's sort of similar to that south of Farmington place I was showing you. And I just adjusted the focal length so that I could get, there's the sun and the moon. This is around the time of max eclipse. And I zoomed it so that it's an equivalent of 24 millimeters, so sort of a medium wide angle lens. Look how minuscule the sun and the moon are in that shot. They're tiny. So if you try to shoot it like that, it may not have the photographic impact you want. And you're going to have a solar filter on, so you're not going to see anything else other than the unobscured part of the sun. That's all that you will be able to see through the solar filter, because the light reduction is so much. So you can't really take a shot like this. I mean, you could maybe cheekily snap one or two on a wide angle like this and have a relatively low risk of damaging your camera. We've probably all taken, starburst shots where you take the sun just peeking out from behind the branch of a tree and you stop down your aperture and you get that star effect. And we haven't necessarily killed our cameras by doing that. But it's not really the recommended approach for an extended annular eclipse where really your focus is the sun. Here it is again, zoomed into 136. I was trying for 135 to match it up with a standard lens, but my fingers weren't quite accurate enough. And you can see, yeah, it's starting to show up a little bit more reasonable, but there's no foreground based on the altitude of the sun at this point. There it is, 500 mil, say, at the time of max eclipse, and you can sort of see you're not going to see this texture in the surface of the sun. That's just how the software represents it. It wasn't really designed for eclipse simulation, this app, but it does give you a sense of the relative size of these things. So a long telephoto lens will get you more sun, more lunar limb, and if you're at the edges, some of those edge effects as well, potentially. Then finally, this is my last slide on focal length and field of view. let's say you did want to do a composite of this event. Probably what you're going to want to do is to photograph your foreground without the solar filter, but you may still want to put an ND grad on or have a sort of underexpose it to some degree to match it in with the black mood of the solar filter shots. So you could capture that. You could either do two things. You could just shoot the whole thing wide angle on an intervalometer. You set the camera once. You won't need to move it as long as you have adequate field of view. This is showing 17 mil, so a wider angle than before. That's C1, start of partial. This is C4, end of partial. And that is enough if your camera were in landscape orientation to have some foreground in and capture the path before these disappear off the top of the frame. So that gives you an idea of how you could do that. You may also want to just capture some foreground shots to give you options once you've settled on a location. You could do that the day of, you could do it the day before, you could do it on a spare camera. Take some wide angle foreground shots without a solar filter, one or two. Try not to do it much, and do not do it with a telephoto pointing at the sun at all. And then you would have that in stock for later compositing with your shots of the progress of the sun and the moon through the eclipse. And you could take those at a longer focal length with your solar filter on. It's then probably a lot of work in post production to assemble that and work out how do I balance the partially eclipsed sun with the black, everything else around it is black because of the solar filter, with your foreground shot. But you're not going to do any of this in camera. This is all going to be post. Okay, so let's just talk about some practicalities. So here's me sat on the front porch the other morning, and I would highly recommend you do this if you haven't done it already. Before eclipse day, practice shooting directly into the sun. And this is my personal experience, is that it can be somewhat stressful, because it's hot, it's bright. It wasn't even a particularly hot day, but the fact that you're sitting there pointing the equipment right at the sun, with sitting behind the sun, trying not to get blinded and yet still control what your camera's doing, it can be a bit of a tricky situation. And so what I did for this, our plan, as you may have guessed, is to go to New Mexico. I'm not worried about doing a composite shot. I'm going to focus on telephoto stuff. So we're going to New Mexico. I want to show you this quickly. October 14th, 23. By the way, to show these eclipse paths, all you have to do is to type in the date of the eclipse. The ones for October and this year and next year are available free. Other eclipses are available if you have the pro subscription. But just go to the date of the eclipse and it should show up. If it doesn't show up, try just going backwards and forwards. Sometimes if you change the pin location, time zone needs to get updated, that sort of thing. Anyway, here we are, more or less central line at maximum eclipse. One of the useful things you can do on this site that you don't always have easy access to on other pages is what is the direction of the sun and the altitude of the sun and moon at the time of the eclipse. So you can see here in the timeline that, well, there's the direction. So you see we're pointing southeastish, and it's up at 34 degrees above the horizon. That's the elevation angle or altitude. So I went out here in Colorado the other day, at the time of morning, around 10 o'clock, when the sun was more or less at that altitude of 34-ish degrees. And that's a really valuable exercise, because then you can check two things. One is, how do I want to sit? How do I want to position myself, position the camera? Can I achieve the angle I need with my tripod and ball head combination? Do I need to rotate things so that the camera can be tilted farther back than I normally use to shoot? All of that is well worth trying out ahead of time, so that you're not sort of in a flap panicking to try and get those things comfortable on the day. Things to bring: water, sunscreen, hat, shade. This is a sun umbrella. A camping chair is almost certainly going to make life a lot more comfortable. You may want to bring a towel for your camera just to protect it from the heat if it's sat out there for a long time. Sunglasses for when you're not looking at the sun but just sat there. If it's a nice blue day as this was, and we hope it will be on eclipse day, you're going to want to have some sunglasses at hand. Eclipse glasses, if you're looking at the sun and not looking through an electronic viewfinder, and if you can, an assistant will make life a lot easier. So Alice very kindly took this photo of me, but she was also helping me hold this umbrella while I was trying to get the camera focused and so forth. So try that. I think that'll be useful. Here's the sort of stuff I'm taking. I've got a 200 to 500 SLR body, 70 to 300, a wide angle in case we do any other photography on the same trip, and then some bunch of solar filters. I've got 3 types of solar filters, 2 of different sizes. I'm going to show you those and how they perform next, actually. So cameras, lenses, solar filters, filter holders, elastic bands for sheet filters, and also potentially for your eclipse glasses in case they break. Batteries, chargers, sensor cleaning kit, all the usual stuff. That's not everything I'm taking, but that's a sample of it. Let's talk about solar filters. So these shots were all taken just a couple of mornings ago on the front doorstep at around 10 a.m. with 3 different types of solar filters. So this will give you a sense of what they do. These 2 were taken on a Nikon D800 at 500 millimeters. This one, because we only had the 77mm version of it and not the 95mm, which you needed for the 500mm lens. This was taken on a 70 to 300 on an APC or DX format, so a crop sensor, and then I've sort of resized them to be the same. And I also normalized these to be the same color temperature. So I took the auto white balance of this, and in Lightroom, I set these to be the same light balance, just so that you can see the different sorts of color casts that you get from different types of filters. So this one, this is from Star Guy, who basically, I think what they do is they buy this thing called Barda film, which is used widely by astronomers for telescopes. It's like a mylar sheet. I'll show you a picture of it next. At least I think I had a picture of it. Maybe I forgot to put that in. But it's sort of like a crinkly material that they've cut out and mounted into a round thread screw. So this threads in onto the front of your lens. To be honest, it looks a little bit hokey, but it works perfectly well, and it's quite normal that this film isn't completely smooth. It's not like a glass filter. So when sometimes you see reviews that say, "Oh, the filter it wasn't well manufactured. It was, wrinkles." That's perfectly normal and basically unavoidable with these things. So that's that one. Slightly bluish greenish cast. You can obviously fix that in post, but essentially you're going to normalize that more or less to a white image of the sun. You can see sunspots there. They're pretty sharp actually on all of these shots. Those are things you can capture with solar filter very, very easily. And there's a lot of it going on because we're near a solar maximum, as you're probably aware from aurora reports and the like. So lots of sunspots going on to see. This is from a company called Nisi. It's a solar filter. It's basically a solar approved ND with 16.6 stops, but it is designed as a solar filter, not just as a neutral density filter. It produces a white image. If you max out the saturation on this, you'll see there is a little bit of color around the limb there, which you can. It doesn't look great when you sort of max out saturation, but it is there, but it's mostly white. The final one is from a company called 1000 Oaks in California, and this is an optical black polymer solar filter sheet. So it's a different material than this Barda film filter. and it produces this orange uh, color, which is quite attractive. But it's artificial. It's not sort of revealing some magical orange color of the sun. That is an artifact of the filter. So you'll want to decide whether you like that, dislike it, whether you want to fix it in post or not. A little word on cost of these things. This one, I think, was around $80, $90. I think I should have double checked, but something like that. This one was around. No, I think that. Sorry, this one's around 80 or 90 or 100. Depends where you buy it from. This was a little bit more. This was literally a sheet that I put on the lens with elastic bands, and it costs around $12, and it works. You just need to have robust elastic bands and not get worried about the fact that it looks creased. If I come back, let's go back a couple of shots. That's, oh, sorry, hold on. That's it there on, that's that filter on the end of the lens there. I forgot to put the close-up of that in, but essentially you wrap the sheet around, you tie elastic bands around it, make sure it's secure. You don't want it to fall off. That would be disaster. And you can shoot straight through the slightly crinkly filter sheet, and this is what you get. So again, when using these, and particularly with this one, you do not want to look through the optical viewfinder. It's still not dark enough to protect your eyesight. Just think, with a 500mm lens, you're so focused, you've got so much sun and so much of that energy coming through. Even during an annular eclipse, it doesn't matter that the sun is, 90-something% obscured. The bit that is unobscured is enough to damage your camera and damage your eyesight. So please use live view, shut off the optical viewfinder if you can, use an electronic viewfinder, etc. So those are solar filters. These were the exposures I used, slightly haphazard approach, but f8, because that's the best aperture for the lens. I don't have a ton of experience with this lens, but reading reviews online and people who've really analyzed this, it's going to be sharpest at around f8. So f8 it was. 2500th of a second ISO 200 for this one. 6400th of a second ISO 200 for this one. So that's stopping more light, even though you can't look through the viewfinder. This one, 2500th of a second, but at ISO 1250. So that one's also sort of, what is that? That's lighter, isn't it? So faster ISO speed. I think I just forgot to try and tweak that ISO speed down, to be honest. But anyway, those are the sorts of exposures you're going to use. You're going to need to test this depending on the filter that you have and the lens and so forth. You should sort of establish your exposures ahead of time. During the annular eclipse, the exposure is not really going to change. If you're, let's assume you're shooting telephoto at the sun moon, it's not really going to change, with one caveat, which is what I'm going to talk about next. So once you've established a good exposure, you can run with that. It's often worth bracketing your shots if you can as well. I think that gives you an element of safety. Or it's certainly worth bracketing and shooting, bracketed bursts of shots if your camera supports that. As you get towards C2 and C3, because that's the most important time of the eclipse. It's probably what you're going to remember the most. And this is where you need to think about exposure. So there is this effect called limb darkening. So this is the back of the camera the other day. This is not an annular eclipse. It's an overexposed image of the full sun with solar filter on the camera, with the highlight flashing enabled. So the black that you see is blown out pixels. I took those into Lightroom. This is the same shot here, as shot with the highlight clipping enabled in Lightroom's develop module. And you can see that's blown out. So what you can do is, if you manually then bump the exposure one stop or two stops in Lightroom and see how the overexposure extends, this is giving you a sense of how much darker the limb of the sun is than the center of the photosphere. So what that means is that during annularity, when really it's only the limb that's visible, if you're in the central path, you may need to bump your exposure up to get it back to where it was during the partial phases, because this is darker. And there's a variety of advice online about how much you need to do this, but some people say one stop, some say two, some say more. Experiment, and if you're uncertain, just bracketing. So what I tend to use for this sort of thing is five frames of five bracketed frames with one stop intervals. So it's 2 below, 1 below, 0, +1, +2, and that gives you plenty of latitude. I assume everybody will be shooting in RAW. Definitely do that if you're not. That gives you the chance of recovering anything that did get blown out after the event. So think about limb darkening. Next thing to think about, we talked about focal length and lens selection and so forth, but obviously the sensor size matters as well. I mentioned that in our test shots the other day, we'd had used both a full frame and a crop frame camera. This is the difference. So this is both shot at 500mm. This is on D800, so 36 megapixel at 500 mil. This is on a 24 megapixel DX camera at 500 on the lens, but that's a 750 mil equivalent. So you're getting more pixels of sun for that combo than you are for this one. They're both shown at 100%, so you can compare the size there. But the other consideration before you say, I'll have this one, it's just better, think about the cameras you have available. Think about the number of frames per second they can support, because if you want to shoot continuously at especially C2, C3, then that becomes important. The buffer size, is it going to stop shooting after a while if you're shooting continuously? And this is doubly important if you feel that you'd like to bracket as well. You want to be bracketing and then shooting frequently to catch all the things that might be observed during the eclipse. Autofocus performance is important. It was harder to focus the cheaper APC format camera than it was the D800. So think about that. Live view screen brightness and resolution. One thing I found, I was wearing a light colored top the other morning, and it was reflecting in the back of the live view screens, not adjustable, not angleable. So you might want to think about wearing something dark, because you might be sitting under some shade, trying to see what's coming through live view. It can be hard, particularly if you have something bright that's reflected in that. And then just overall camera handling, which are you most comfortable using? You want to be using a camera that you're familiar with, so that there are no surprises, or you're stopping to think, how do I do this right in the moment of the eclipse? Okay, let's talk about a few. I'm getting into we're in the last couple of slides now, and I'm into the geeky section. One thing you will see on, or you may see on eclipse information sites, is a thing called delta T, and you'll see it here. I have this thing called delta T, and you see it says 69.19 seconds. And you're thinking, what is that all about? And it's a good question. It's something that eclipse chasers do keep an eye on. What it is to do with is the rate of rotation of the Earth is not a constant. It sometimes speeds up, it sometimes slows down. And if you imagine what that means, just imagine for one moment the sun and the moon are fixed in the sky. Let's just make it simple. And all that's happening is that the Earth is rotating underneath them. If the rate of rotation changes, then you standing in, let's say, San Antonio, Texas, the time at which you arrive into the path of the eclipse can change if the Earth was on a go slow or a go fast. So that's basically what delta T is doing. So the calculations all use a sort of a fixed reference time, and delta T is just used to convert between universal time that our clocks use and the dynamical time. There are other terms for this that the astronomers use. This delta T is not predicted with 100% accuracy, but it's pretty good. You might see a couple of tweaks between now and next April. The one for October is pretty much set. And just to let you know that you probably don't need to worry about it, but if you're wondering what it is, I made a change of 0.7 seconds in delta T for the April 8th, 24 eclipse path. And this is how far the path moved as a result, about a car's length. But if you're looking sort of, further out, or you're looking at data, check what value they're using, particularly if you're planning on going towards the edge of the path. That's when this becomes important. That's delta T. More important, the lunar limb. Over the course of years and the moon cycle, sort of 19 years, roughly speaking, we on Earth are able to see around 59% of the moon's total surface. The rest of it, the dark side of the moon, as we're all familiar with, you never see because it never moves, it never rotates into a viewable position for us anywhere on Earth. But this variation in the bit that we do see is called libration. That's the technical term for it. And it's sort of movement in that axis, movement in that axis, and then there's the position angle which rotates it around. So think of it as sort of a wobble in the moon. And then during an eclipse, when there's a certain libration is in effect, then the edge of the moon that we see, or the edge of the moon that's presented against the disk of the sun, changes. And that can give rise to this phenomena called Bailey's beads, which is what is shown here. This is in a total eclipse, not an annular eclipse. There's no filter, there's no solar filter on that camera. You can tell by the sort of the glare and the spread of the beads. Unlike that image I showed earlier, remember, where they looked sort of fairly flat and tame. So annular eclipses are very good for seeing this. And the general advice is, for the best chance of observing extended Bailey's beads, locate yourself a couple of miles inside the northern limit line. And that has to do with, this is the libration, this is the profile of the moon as will be seen in New Mexico on the 14th of October. But you can see that the height is exaggerated, just so you can see it, because it looks pretty flat, but it's present. But with exaggeration, you can see that that part of the moon is a lot smoother than this part. So if the contact times work out to be this part of the moon's disk, then that's where you get a lot of these Bailey's beads. And generally speaking, if you go to the northern limit of the eclipse, you're seeing the shadow. You're not seeing the shadow. You're seeing the southern part of the limb. Is what causes the Bailey's beads. You can also see them at the southern limit, but they may not be quite as pronounced. Again, if you're looking to photograph this and you haven't photographed one of these before, if you can find somebody who's done it before, go with them. That's probably the best way to do it. I'm going to give you a few resources you can explore if you want to look into this further before the day comes. Edge phenomena. This is a total eclipse, but I'm showing it just to remind you of the sort of things that can be seen: the chromosphere, prominences, and the corona. So can you photograph any of those during an annular eclipse? The answer is yes, but with some difficulty and some risk. Best attempted at an edge location, because we want to keep the moon's limb near the sun's limb. So let's just quickly look at such a location. So I'll come up here to, sort of Mesa Verde, something like that. So I'll go a little bit further, but I'm a few miles in from the limb. Let's just measure how far in you are. I'm using the geodetics tool, so I click enable that gray pin, I drop it, and then it's sort of a measuring tool, so you can see them 10 miles in from the path limit. I'm going to go a little bit closer. So say something like 5 or 6 miles within the limit, and then let's go to second contact. And then if I click 5x and just play this back, sort of watch how the limb of the moon creeps, sort of rolls around the edge of the limb of the sun. And that means that basically at all times it's behaving a little bit more like a total eclipse, but just in this contact area here. And that's where you can see, this is, here we are. So we're out of it already. So it's short, but you get those edge effects. That's where you can potentially see some of these phenomena that are usually more associated with total eclipses during an annular eclipse. But here's the challenge: you have to, if you're going to photograph it, you'll not see them if you keep the solar filter on. But if you take the solar filter off, you run the risk of damaging your eyes, damaging your equipment, etc., etc. So what some photographers have done, this is very much an advanced technique. I've never tried it. I don't plan to try it this time. Is to use a gobo, which is theatrical term for sort of a light profile thing. So you can sort of essentially block out the photosphere of the sun and just leave the part that is obscured or with the chromosphere visible to your camera, telescope, etc. This shot popped up on Facebook this morning. This is by Thierry Legault, who's a famous astrophotographer in France, who photographed the youngest ever new moon. And when he was doing it, he used this to block out. The moon is obviously not eclipsing the sun, but it's very close to it, and he wanted to avoid the risk of any sunlight getting through to that camera telescope setup, and he did it with this sort of cutout. Not advising that's what you should do for the annular eclipse, but it's a measure of the degree of planning that is involved. Okay, final geek point. Very small point, but I want you to be aware of it, just so that there are no surprises. Elevation corrections to these paths. When you look at these paths, switch that off. They are all calculated generally, and particularly for these interactive maps like this one, where you can zoom and pan. I'm not aware of any interactive eclipse map that includes the paths corrected for elevation above sea level. So these paths are calculated assuming a perfectly round sphere of sun and moon, and where it would project onto not a spherical Earth, but the ellipsoid Earth, but the smooth ellipsoid Earth at sea level. So what that means is that if you're several thousand feet above sea level, then the limit line actually moves a little bit. So if you want to get into this, I'm just going to glance over this, but look for the International Occultation Observer's Manual, and you will find everything you want to know about how to do these corrections. It's something I'm going to try and build into the tool because it's pretty simple. So let me give you an example. This is from their manual, and it's a little bit of trigonometry to do it, to work out what the fix is. So I have a little setup here that we can do this for. So here's New Mexico, and I'm going to show you how to do this little limit. What you would do is you would check, what is my elevation above sea level, 5,900 feet. I have this plugged into a little spreadsheet at the moment, but how to do it is in this manual. You plug in your elevation above sea level, the altitude of the sun, the azimuth of the moon, all of which you can just read straight off here. And then the last thing you need is the path azimuth. What does that mean? The path azimuth is what is the bearing of this eclipse path. So we can use geodetics to get that. I'm just going to put one pin there, read off the azimuth 124 degrees. That's the bearing from true north. I plug that into my little formula back over here, and I get a correction of 1,165 feet. So that's the correction to the limit line. So what that's saying is that, in fact, at this location is a little higher. Sorry, it's the wrong tab. What's the tab? That's the tab I want. We're at 5,900 feet. This was the example I was using. I'll bring that in. You want to sort of be about 1,000 feet south of there. So it's a small adjustment, but if you're worried about getting these plans spot on, you might want to look at doing that. So the limit line at this elevation is around 1,000 feet further south. That's that. It's called the Tan-Z correction. If you read about it, that's what it's all about. Okay, and then here we are. Upcoming dates: 14th of October. That's the one in pink. April 8th. That's the one in green. So lots of exciting things coming up. I've got 10 minutes. That was a lot of stuff. Thanks for sticking with it. And let me look at some questions now. Let's have a look. So I've got Yeah. Okay. So what I should do? I'm going to put in some links and things into the chat. So let's have a look. So Joel also suggested this site for weather, cleardarksky.com. So that is a good site. The other one that I'd mentioned was windy.com. And let's just get back to, oh yeah, the other one was eclipsophile.com. That is an excellent site. These are all for weather. So and this is a good one, teleconverter. Can I use a teleconverter? You can. If you haven't used one before, it's triply important that you go practice beforehand. I tried one. I tried a 1.4 the other day, and I found it so difficult to achieve focus with the teleconverter on that I gave up on it altogether. Particularly we can see I'm wearing reading glasses, and trying to just see whether I was having to manually focus because it wouldn't autofocus through the teleconverter. If you can focus it successfully, then by all means go for it. Generally speaking, it may be more trouble than it's worth. So that's in answer to John and Mike's questions. Oh yeah, and Audrey's question. Yes, I know. I want to maximize the size of the sun too, but I found that I think a better answer would be to go to a crop sensor than a rather than a full frame, rather than use a teleconverter. I've been through exactly that debate. It's tricky. So Rick asks, where in TP can you simulate seeing the sun using various focal lengths? To do that, I was using, let's have a look, Ephemeris. I was using an iOS app, and specifically I was using this one, Ephemeris 3D. So with that, you can sort of use pinch to zoom to simulate different full frame equivalent focal lengths for that. 2 minutes to go, and I just see Mike's question here. This is a good one. Let's just talk about that. He's asking about altitudes. I was going to show this and I sort of forgot. But if you're shooting this eclipse in a mountainous area, okay, let's say Albuquerque. That's a good idea. So Albuquerque sort of lives right next to a big mountain. This thing here. So it's right on the central path. Let's say you're living somewhere in this little neighborhood here of El Dorado Heights. I don't know it, but I've just alighted upon it. And we go to the time of max eclipse. There it is. I'm just going to click that off, put my geodetics pin here. So that's geodetics. I'm putting it on the mountain ridge, and I'm going to the time of max eclipse. The sun is at 36 degrees. The altitude from the oh no, sorry, I was on the wrong time. There you go. Let's tweak this. I want to sort of make it a little bit more realistic here. So we're sort of in the lee of this mountain here, or not the lee. You want to check whether you can actually still see the sun. You can use the geodetics pin, just measure the altitude. So I've dropped the pin on the ridge, the red pin where I'm shooting from. I've got the time of maximum eclipse. The sun and the moon are at 36 degrees. The altitude is +7 degrees. The other thing you can do to visualize it is use the 3D function in the web app, and you can see quite clearly that, yes, there's a ridge, but the sun is way up above it. So if you're shooting anywhere near some uneven terrain or mountains, use these tools, geodetics and the 3D terrain in the web app, just to check your sight lines. That's a super important thing to do. So that's, Mike, that's your question. Trisha asks, can you look at live view without solar glasses? Yes, and indeed, Trisha, you must, because otherwise you will not see anything at all. You won't even see your camera in front of your nose if you have the eclipse glasses on. Okay, I think we've hit time. Hopefully I've managed to answer most of those questions. Thanks again so much for joining. You'll get the survey pop up. If you can answer it, great, much appreciated. And good luck with your eclipse photography on 14th. And hopefully we'll see you at another webinar soon. Thanks again.